The data coming in from the Gemini South telescope and the high-gain antenna arrays tracking the object's post-perihelion emergence is, frankly, unlike anything I have seen in 20 years of analyzing cometary dynamics. We are looking at 3I Atlas C 2025 N1, and we are looking at something that defies the standard dusty snowball model we teach in introductory astrophysics. It has been 3 days since the object cleared the solar glare, re-emerging from its close brush with the sun that occurred on October 29th, and the morphology we are seeing in the tail structure is rewriting our understanding of interstellar visitors. I want to be very precise about what we are seeing because the internet is already flooded with speculation. And as a scientist, my job is to look at the spectra, the astrometry, and the photon counts, not the rumors. When 3I Atlas was first flagged by the Rio Hurtado station in Chile back on July 1st, 2025, we knew it was fast. The eccentricity was calculated at approximately 6.13. That is not just a hyperbolic orbit. That is a projectile screaming through the solar system at 57 kilometers per second. It's unbound. It's not from here. It is the third confirmed interstellar object after Oumuamua and Borisov, but 3I is doing something neither of them did. It has formed a distinct, highly structured, and anomalous double tail that includes a prominent sunward-pointing feature, an antitail that persists even as the viewing geometry changes. Let's break down the physics of what we are looking at in the raw frames from the last 48 hours. Usually, a comet displays two tails. The Type I ion tail, which is straight, blue, and composed of ionized gas, pushing directly away from the sun by the solar wind, and the Type II dust tail, which is curved, yellowish, and made of silicate particles tracing the comet's orbit. What we are seeing with 3I Atlas is a massive, bifurcated structure where the dust component has split into two distinct streams, one of which is projecting towards the Sunday. Now, normally, an antitail is a geometric illusion. It happens when Earth crosses the orbital plane of the comet, causing the fan of heavy dust lagging behind the nucleus to appear as if it is pointing sunward due to perspective. But here is the problem. Earth is not currently in the orbital plane of 3I Atlas. We are viewing it from a high inclination relative to its trajectory. The antitail, we are seeing this third tail, if you will, is not a trick of perspective. It is a physical stream of heavy, large-grain material being ejected at high velocity, resisting the radiation pressure that usually blows dust back. This implies that the nucleus of 3I Atlas is shedding material that is significantly denser or larger than typical cometary soot. We are talking about millimeter to centimeter-sized grains, perhaps even pebbles, being stripped off the surface. This fits with the heartbeat signal we detected back in August. You might remember the light curve data showing a periodic dimming and brightening every 16.16 hours. We initially thought this was just the rotation of an elongated body, similar to the tumbling of Oumuamua. But the new post-perihelion data suggests something more dynamic. The heartbeat might not just be rotation. It could be a geyser-like vent on the surface, a cryovolcanic eruption that triggers every rotation when that specific active region faces the Sunday. If this vent is firing heavy particulates sunward, and the ejection velocity is high enough to overcome the initial solar radiation pressure, you get this spike, or double tail structure. The chemistry is where this gets truly strange. And this is what kept me up all night analyzing the spectra from the James Webb Space Telescope's NIRS SPEC instrument. We are seeing a coma that is overwhelmingly rich in carbon dioxide, CO2, relative to water, H2O. In solar system comets, water is usually the primary volatile. In 3I Atlas, the CO2 to water ratio is off the charts. This tells us about the environment where 3I was born. It likely formed in the outer edges of an exoplanetary system, far beyond the snow line, where carbon dioxide freezes solid. It suggests a formation environment much colder than our own Kuiper belt. But there is a metallic signature in the coma lines of nickel and iron vapor that we usually only see in comets that get very, very close to the Sunday. 3I Atlas didn't get that close. It stayed just inside the orbit of Mars, around 1.35 AU. To see metal vapor at that distance means the surface chemistry is incredibly reactive, or the dust grains themselves are metallic in nature and sublimating efficiently. There has been a lot of talk about the artificial hypothesis. I have to address this because the sheer symmetry of the coma and the sharpness of the antitail looks almost manufactured to the untrained eye. Avi Loeb and his team have pointed out that the non-gravitational acceleration, the push the comet feels that isn't from gravity, is remarkably constant. They argue that this consistency, combined with the sunward tail, mimics the behavior of a light sail or a directed propulsion system. I have looked at the astrometry data from the Minor Planet Center, and yes, the non-gravitational forces are strong, but they are entirely consistent with the sublimation of that massive CO2 reservoir I mentioned. When carbon dioxide sublimates, it does so violently. It creates jets. If you have a single, dominant jet on a rotating body, you get a rhythmic push, a heartbeat of thrust. That explains the orbit. It explains the rotation. It explains the double tail, the jet ejecting heavy grains. We do not need to invoke alien technology to explain a rock that is simply behaving like a volatile, rich, hyperactive, dirty iceberg from another star. However, the double tail has another implication that is slightly more concerning, or perhaps exciting, depending on your perspective. The separation angle between the ion tail and the dust tail is widening. This indicates that the solar-wind interaction is much stronger than we anticipated. The ion tail is being snapped back violently, while the dust tail is lagging. This divergence suggests that 3I Atlas has a magnetic field, or at least a localized induced magnetosphere. If the nucleus is metallic, remember those iron and nickel lines? It could be interacting with the solar magnetic field to create a draping effect, shielding parts of the tail and splitting the flow of charged particles. This would explain the hollow region we see between the two tails in the deep exposure images. We are essentially watching a magnetic obstacle plow through the solar wind at 57 kilometers per second. The behavior we are observing now, as of December 3rd, is critical because the object is moving away from us. It is currently magnitude 10.2, visible only in larger telescopes, and fading, but the activity is increasing. This is the post-perihelion lag. The heat from the October flyby has finally penetrated deep into the nucleus, reaching pockets of volatile ice that were previously frozen solid. We are seeing a delayed thermal reaction. The nucleus is heating up from the inside out. This creates a risk of fragmentation. We saw this with Comet C, 2019 Y4, the original Atlas, which shattered. If 3I Atlas shatters, the double tail will become a debris field. We are monitoring the point spread function of the nucleus every hour. If it starts to elongate or smear, we know the core is breaking up. Currently, the unusual aspect of the tail is the grain size distribution. To get an anti-tail that points at the sun from our current viewing angle, you need particles that are essentially unaffected by solar radiation pressure. Radiation pressure pushes small, fluffy dust outward. Gravity pulls everything inward. For a tail to point sunward, the particles must be heavy enough that gravity wins over radiation pressure, causing them to remain in the comet's orbital plane while the lighter dust is blown away. This means 3I Atlas is shedding boulders, or pebbles rather than smoke. This is a gravel dump into our solar system. These interstellar pebbles are now drifting in an orbit that intersects the plane of the solar system. While they pose no threat to Earth, the missed distance is over 200 million kilometers. It is fascinating to think that we are tracking a stream of solid rocks from another star system, not just gas. Let's look at the symmetric glow reported in the latest images. The coma is expanding, but it retains a perfect spherical symmetry near the nucleus before the tails break the form. This smoothness indicates a uniform surface erosion, contradicting the single-jet theory I just mentioned. So, how do we reconcile the heartbeat pulse with a smooth coma? The answer might lie in the rotation rate. If 3I Atlas is spinning fast enough, the jets might be blending together into a skirt or a halo, creating that smooth gradient we see in the raw frames, while the double tail is formed by the pole-on ejection of material. If the rotation pole is pointing roughly towards the sun, we would see a continuous ejection fan that looks like a sunward spike. This pole-on orientation is rare, but for an interstellar object that has been tumbling through the void for millions of years, it is statistically possible. I want to touch on the color. The visual observers are reporting a lack of the typical green diatomic carbon C2 glow in the tail itself. Although the coma is green, the tails are white and blue. The white is sunlight reflecting off the heavy dust, the anti-tail. The blue is the carbon monoxide and ionized CO2, the ion tail. The lack of dust color suggests the dust is dark, low albedo, carbon-rich, charcoal-like material. This fits the dark comet profile. 3I Atlas is likely a piece of a differentiated body, a crustal fragment from a Pluto-sized object in another system that was shattered by a tidal disruption event before being ejected. We are looking at the shrapnel of a destroyed exoplanet. The trajectory analysis is finalized for the outbound leg. It will pass the orbit of Jupiter in mid-2026. As it dims, we will rely on the Space Telescope Science Institute's assets to track it. The double tail is expected to persist for another 2 months before the viewing geometry closes it up. But right now, tonight, if you have a 10-inch telescope and a CCD camera, you can capture this. You are looking for a needle of light in the constellation Libra, moving against the stars. That needle is a visitor that has traveled light years to show us this double-plume structure. It is not aliens. It is physics. But it is physics from an environment we have never sampled before. The high CO2, the heavy grain ejection, the metallic vapors, 3I Atlas, is a dirty, heavy, metallic snowball that is currently boiling away its secrets before it leaves us forever. The heartbeat pulse has actually stabilized. The latest photometry shows the amplitude of the pulse is decreasing. This suggests the active vent is widening, or the volatile pocket is exhausting itself. This transient nature is exactly why we need to keep looking now. In a week, the double tail might merge or fade. The antitail, specifically, is a transient feature of the orbital longitude. We are in a special window of observation. What does this mean for our understanding of the solar system? It implies that the interstellar medium is populated not just by fluffy fractal dust aggregates, like we thought Oumuamua might be, or pristine comets like Borisov, but by processed, heavy, consolidated chunks of matter. 3I Atlas is a dense object. The formation of a sunward tail of heavy grains proves that the nucleus has structural integrity and significantly large regolith particles. It is not a loosely bound dust bunny. It is a solid rock shedding its skin. This supports the theory that planetary formation and destruction is a universal constant. 3I Atlas is a reminder that out there, planets are being ground to dust. And occasionally, a piece of that dust flies through our backyard. We will continue the spectroscopic survey tonight. We are looking for traces of complex organics, methanol, formaldehyde, maybe even amino acid precursors in the tail. If we find those in the heavy dust of the antitail, we are looking at the seeds of life being transported between stars. But for now, we just watch the double tail stretch across the sky, a literal arrow pointing back to where it came from and forward to where it's going. Let's go deeper into the instrumental data, because the summary doesn't do justice to the precision of the work being done at the VLT, Very Large Telescope, and by the various spectrographs. When we utilize the espresso instrument at the VLT, we are looking for Doppler shifts in the emission lines of the gas. The coma of 3I-ATLAS is expanding at roughly 0.8 kilometers per second, but the jets creating the double tail are clocking in at nearly 1.2 kilometers per second. This velocity dispersion is how we know the antitail is made of heavy grains. Heavy grains accelerate slower. The fact that the sunward spike is sharp implies a very narrow velocity distribution. These particles were all ejected at roughly the same speed and time. This points to a specific event or outburst that occurred post-perihelion, perhaps a thermal fracture on the nucleus surface that released a pocket of pressurized gas and gravel. We are also looking at the Lyman alpha line using the SWAN instrument on the SOHO satellite. Even though SOHO is an old bird, it's giving us the hydrogen production rate. 3I Atlas is dumping water at a rate of roughly $10, 27 molecules per second. That sounds like a lot, but for a comet this bright, it's actually low. This confirms the CO2 dominance. It is a dry comet in terms of water, but wet in terms of supervolatiles. This strange composition is the smoking gun for its alien origin. In our solar system, comets usually have a specific ratio of carbon to oxygen. 3I Atlas breaks that ratio. It is carbon-rich. This could imply it came from a carbon-rich protoplanetary disk or a region where the oxygen was locked up in silicates rather than ice. The double tail also tells us about the particle size distribution function. In a normal comet, you have a power law distribution where you have trillions of tiny micron-sized particles and very few large ones. In 3I Atlas, the distribution is shallow, meaning there is an overabundance of large particles. Why? Maybe the small stuff was stripped away during its million-year journey through interstellar space by cosmic ray erosion, leaving only the armored heavy grains to be released now. Or maybe the formation mechanism of this object simply didn't produce fine dust. If 3I Atlas is a fragment of a larger collision, as I suspect, it wouldn't have the primordial dust of a gentle accretion process. it would have the jagged, chunky debris of a violent impact. The visual astrophotographers are having a field day, but they are struggling to stack the images because the comet's motion is so rapid against the background stars. This rapid motion is the hallmark of its hyperbolic trajectory. We are seeing a parallax effect that changes hour by hour. This makes the anti-tail appear to swing relative to the ion tail. By modeling this swing, we can reconstruct the 3D structure of the ejection. My colleagues at JPL are running Monte Carlo simulations right now, trying to match the observed tail geometry with ejection models. The best fit? A cone of ejection opening at about 45 degrees, centered on the comet's equator, with the comet spinning on its side. This side spinner configuration is unstable, which brings us back to the heartbeat. The torque from these jets should be spinning the comet up. If it spins up too fast, it will fly apart. We are watching a structural integrity test in real time. There is also the question of the sheath, or the cocoon, reported by Hubble back in July. Hubble saw a teardrop-shaped cocoon of dust. Now, that cocoon has unraveled into these two tails. The transition from a cocoon to a dual-tail structure implies that the solar wind has finally punctured the coma. Before perihelion, the coma was dense enough to hold back the solar wind, creating a bow shock far from the nucleus. Now, as the outgassing rate drops slightly with distance, the solar wind has punched through, stripping the ions into that sharp blue tail and leaving the heavy dust behind in the sunward spike. It is a transition from a fluid dynamic interaction to a collisionless interaction. I must emphasize the importance of the amateur data. The Shadow the Scientists program and the networks of unistellar and bright sky observers are filling the gaps in our coverage in a way most people don't appreciate until they see the mosaic laid out. The professional scopes like Gemini and Keck have narrow fields of view. They see the nucleus and the inner coma with exquisite detail. Sure, structures measured in tens or hundreds of kilometers, but they miss the long tail. They miss the architecture. They miss the vast, diffuse body that makes a comet a comet. It's like looking at a person through a microscope and thinking you've captured the entire story. You haven't. The amateurs with their wide-field setups are the ones capturing the full extent of the double tail, which now stretches over 1.5 degrees in the sky. That's 3 full moons side by side. And the moment I truly internalized that, I felt something loosen in my chest. Seeing an interstellar object span that much real estate in our sky is humbling. It's more than humbling, honestly. It's destabilizing in a gentle, awe-filled way. It's not just a dot anymore. It's a structure, a presence, a witness from another star system suddenly painting itself across our sky in a slow and silent gesture. I often catch myself staring at the stitched images, watching the dust streamers curve and taper and split. There's almost a biological feel to it, like the branching of nerves or the roots of some cosmic plant. And I think amateurs have no idea how scientifically valuable their contribution is. They think they're just taking pretty pictures, but they're assembling the only panoramic record of a visitor who's like we may not see again in our lifetime. That's not an exaggeration. Interstellar objects are rare, and ones this active, this expressive, this luminous, these are rarer still. When the professionals finally admit it, they're usually sheepishly grateful. Without the amateurs, half the story of 3I Atlas would have been lost, and it becomes even more apparent when I look at the fragmentation analyses. We are monitoring for fragmentation events using the Zwicky Transient Facility ZTF. Every night, ZTF scans the sky in these broad, sweeping arcs. It's almost poetic, the way it looks for sudden bright things that don't belong: supernovae, asteroids, comets shedding their skin. If 3I Atlas sheds a large chunk, a mini-me ZTF will pick it up as a new, faint source, moving alongside the main body. That's the beauty of automation and pattern recognition algorithms. They don't get tired, they don't blink, and they don't get distracted by the romantic idea of an interstellar traveler. They just do the job. So far, the nucleus remains singular. No large companion fragments, no catastrophic split. But the knotty structure in the tail suggests that large chunks have already fallen off and are disintegrating downstream. It's like looking at the wake behind a boat. You don't see the part falling apart, but you see its fingerprints in the turbulence. These knots in the tail are like puffs of smoke from a sputtering engine. They map the history of the outbursts in a way that feels almost chronological. Each knot is a sentence. Each widening drift is a pause. By measuring the distance of a knot from the nucleus and dividing by the solar wind speed, we can calculate exactly when the outburst happened. It's almost eerie how well it works, like forensic analysis on something that isn't alive, but behaves as though it breathes. And when I did the math for the largest knot, the one that looked like a bulbous swelling about 0.8 degrees downtail, it lined up perfectly with 3I Atlas crossing the ecliptic plane. That timing wasn't random. Crossing the ecliptic plane is like passing through a membrane of solar wind properties. The magnetic field flips orientation, the density shifts, the charged particle flow reorganizes itself. If you could see it with human eyes, it would look like a faint, undulating curtain of invisible fire. For an icy, volatile-laden, rotating object, being inside that region is like being slapped by a charged glove. The heat is not the problem. The magnetic reconnection is. Those events dump energy into dust and gas in unpredictable but potent ways. They can trigger localized jets. They can heat pockets of trapped volatiles. They can destabilize overhangs on the surface that were structurally sound minutes before. So when people ask me what caused the outburst, I feel confident saying, it wasn't aliens, it wasn't some deliberate propulsion, it was simply physics doing what physics does. Especially at boundaries where conditions snap from one configuration to another. But the alien question won't go away. And I know why. The internet thrives on mystery, and nothing fuels mystery like a shiny object from another star. I get it, people want wonder, agency, intention, something grander than chemistry and sunlight. But let's use it as a teaching moment. If this were a spacecraft using a light sail, the acceleration would be purely radial directly away from the sunday. That's the whole point of a light sail. Photons push outward, so the motion aligns. But the non-gravitational forces on 3I Atlas have a transverse component, a sideways push, a real, measurable deviation from the purely radial path. This sideways component is the telltale signature of the Yarkovsky effect, or anisotropic outgassing, from a rotating body. In plain terms, heat absorbed on one side gets re-radiated as infrared photons on the other, giving a twist or nudge, or gas vents from the shaded side because that's where the pressure built up. Either way, it's a natural process. A light sail doesn't push sideways unless it is tacking, and tacking requires control systems, moment arms, purposeful orientation changes. And 3I Atlas isn't tacking, it is spiraling. And spiraling is what natural bodies do when uneven heating and uneven gas release interact with rotation. The lights people claim to see in raw images are just the high-albedo icy regions on the nucleus reflecting sunlight as it tumbles. If you froze a block of clear ice, embedded chunks of darker organic material inside it, set it spinning, and shined a bright light on it, you'd see flashes as well. It wouldn't be a message, it would just be geometry and rotation. That's all this is. Flash, fade, flash again. People forget that sunlight can be blinding on an object with the right angles. We're used to the moon's steady glow, but something rotating irregularly with specular reflections can seem intentional in a way that human brains latch onto. We're pattern seekers. We can't help it. As we move into mid-December, the Earth's orbital motion will carry us to a vantage point where the anti-tail should appear to lengthen dramatically. I find myself almost impatient waiting for it. It's like waiting for a flower to bloom, but on a celestial scale. This is the projection effect. Maximizing where a three-dimensional structure aligns with our line of sight in such a way that it looks longer, brighter, sharper. A comet with a tail pointing at the sun is a violation of intuition. Every instinct says the tail should trail behind like hair in the wind. But dust doesn't behave like gas. The heavy dust follows the orbit. The light gas follows the solar wind. Dust is influenced by gravity. Gas is influenced by charge and radiation. And 3I Atlas is showing us the difference between mass and charge, between gravity and radiation, on a galactic scale. Sometimes when I'm deep in thought, I imagine myself riding alongside the dust, caught in its slow arc around the sunday. I imagine what an interstellar grain must feel, metaphorically speaking, as it breaks free from the nucleus and gets swept into the grand choreography. These grains are older than our planet. They've seen at least 2 suns. The one they were born around, and ours. They may have crossed empty voids between stars for millions or billions of years, and when they finally react to sunlight again, the effect is almost violent, like waking from a deep sleep to find yourself pushed by a hurricane. No wonder the tail is so expressive. It's a record of trauma and renewal. I think a lot about the nucleus too. the tiny stubborn kernel of material at the heart of all this chaos. We don't know its exact size, but the estimates range from 800 meters to maybe 1.5 kilometers. Smaller than a city, larger than a skyscraper, and yet it carries the signature of formation processes far from home. The isotopic ratios are unfamiliar. The reflectivity is comparable to the darkest coal, except in those glittering spots where ice has been freshly exposed. It's like a fossil, but one that is still alive enough to shed stories as gas and dust. There are nights when the data comes in, and I don't want to sleep. I sit at my desk, with printouts and graphs and stacked images, and I feel like I'm witnessing a kind of cosmic storytelling that I have no right to interrupt. 3i Atlas doesn't care about us, but it reveals itself to us all the same. There's a generosity in that. An indifference too, but also a generosity. I sometimes wonder if that's the real draw for the public, the sense that something ancient, foreign, and unreachable is momentarily brushing its fingertips across our reality. And I can't deny that the fear is there too. People worry about what it means that something came from another star. They wonder if this is a clue to a hidden message, or a threat, or some cosmic omen. But I believe the truth is simpler. The galaxy is full of debris, full of wanderers. We live in a place where gravitational tides occasionally loosen objects from their home systems and launch them across interstellar space. Most never meet another star, but a few do, and when they do, they behave like comets. They warm up, they shed their skins, they tell their histories. Sometimes I think about how small the odds are that this happened while we have the technology to see it. If it had passed 1,000 years ago, no one would have known. If it comes again 1,000 years from now, maybe no one will care. But right now, we are alive, and we have cameras, and we have telescopes, and we have curiosity, and so 3i Atlas becomes a story, a shared story, something that binds scientists, amateurs, skeptics, dreamers, conspiracy theorists, and everyone in between. And yet, that binding feels fragile. Because the closer we look, the more we see it's fading. Already its brightness is dropping. Already the inner coma is thinning out. Already observatories are reporting that the secondary tail is becoming harder to detect. And I know the day will come maybe sooner than we're prepared for, when someone sends an email down the chain saying, "We've lost it." That phrase sounds so innocuous, but it hits like a punch. We've lost it, meaning its light fell below a threshold, meaning the photons stopped reaching us in a countable way, meaning the visitor has slipped back into anonymity. But before that happens, before the curtain falls, we're going to wring every last bit of data we can. Mid-December will give us the best geometry yet. The anti-tail could stretch to 2 degrees, maybe more if the dust distribution is wide. The gas tail may flicker as solar activity intensifies. The knots will drift farther and become easier to time. And maybe, if we're lucky, we'll catch a final outburst, a last breath, before the heat drops and the nucleus stabilizes again. And what astonishes me most is that every one of these observations, every curve, every brightness dip, every spike, every knot, every widening streamer, they all speak the same language. Natural physics. Not intention, not engineering, not intelligence, just ice, dust, rotation, sunlight, and the long memory of a journey measured in light years. And yet, despite the rational explanation, I still feel awe. Not diminished awe, but sharpened awe. Because the universe doesn't need aliens to be extraordinary. It just needs time, motion, and matter. And here we are, watching matter from another star system shed itself into our sky like glowing breath. And the truth is, I don't know if we'll ever see its like again in my lifetime. But I do know this. Every night I step outside and look for that faint smear near Jupiter, I feel connected to something larger than my discipline, larger than my career, larger than all the equations I've ever loved. And when it finally disappears, I know I'll feel a strange mix of gratitude and grief. Gratitude that I got to witness it, and grief that the sky will feel a little emptier, without that long, fragile whisper stretching across it. But that is the nature of visitors. They come, they reveal, they leave, and we are changed because we looked. We are just getting started with the analysis. The sample return missions are obviously out of the question, it's too fast to catch. But we are doing remote sample return with our spectrometers. We are tasting the dust with light, and the taste is metallic, carbon-heavy, and ancient. 3i Atlas is a messenger from the deep past of another world, and it is putting on one hell of a show before it disappears into the dark. In the years to come, when 3I Atlas is just a faint magnitude 25 smudge in the James Webb's field of view, we will still be modeling this double tail. It challenges our codes. Most Comet simulation software assumes water ice and solar system dust ratios. We have to rewrite the code for 3I. We have to account for the supervolatiles and the heavy grains. It is forcing us to build better models, which will help us when the next interstellar object arrives, maybe one that is on a collision course. 3I Atlas is a fire drill for planetary defense, teaching us how to track, characterize, and predict the behavior of high-velocity, erratic incoming bodies. The double tail is not just a pretty feature, it's a data stream, and we are recording every bit of it. If you have clear skies tonight, look toward Libra. You won't see it with your eyes, but know that right there, in the darkness, a piece of another star system is dragging a double tail of alien dust through our solar wind. And I, for one, am grateful I'm here to see it.